Hello everyone. Our topic of the project is the DC-DC converter that powers USB-C devices from a DC input voltage source. We are all JSI students. This is our agenda. As for abstract, the application range of the switching power supply is becoming more and more extensive, and the DC-DC converter is regarded as the core part of the switching power supply. According to whether there is an interval between input and output, DC-DC converters are divided into direct DC converter circuits and indirect DC converter circuits. This project will design the DC-DC converter that powers USB-C devices from a DC input voltage source by using Simulink. And this circuit can realize the function of rectification and the voltage step down. This is our objectives. First, design a transfer-insulated full-bridge buck converter as the main circuit. Second, simulate and verify the circuit in MATLAB Simulink. Third, calculate the design parameters and analyze the test results. Finally, study the bidirectional DC-DC converters and construct the ideal model. As for introduction and background, this project will design a type of transfer-insulated full-bridge buck converter and show its control method. In addition, a basic bidirectional DC-DC converter will be simulated and analyzed as well. The DC-DC converter is generally composed of a control chip, an inductor, a diode, a transistor, and a capacitor. Unidirectional DC-DC converters can be matched with green power sources. As my country's energy demand increased and the environmental protection requirements increase, unidirectional step-up and step-down DC-DC converters have broader market prospects. This is our approach. We divided it into 5 parts. In Figure 1, the input is DC voltage after full bridge rectification through the different excitation signals of the switch. The voltage is transmitted to the primary end of the step-up transformer as periodic square wave, with the inductance of the transformer does not reach the saturation of charging. The secondary terminal will get the periodic square wave after boosting. Finally, D5 and the buck converters work in the forward voltage. D6 and the buck converters work in the reverse voltage. Under the action of two diodes, a step DC voltage and current are provided to the node resistance. Figure 2 is the basic theoretical topology of a bidirectional DC-DC converter. When S2 is switched off, S1 is switched on. This converter is actually a boost converter. When S1 is switched off, S2 is switched on. This converter is actually a buck converter, and the power transposes from V2 to V1. This is the relative parameter change of the second diagram in Figure 1. This is also the working principle. In the different time zones, the parameter changes are not the same. That's shown in this page. Next, we used the Simulink MATLAB to simulate this model. The left figure is the transformer-insulated full-bridge buck converter in simulation, and the right figure is the ideal simple bidirectional DC converter circuit. Next, Kai-Yang will introduce the next part.
Hello everyone, I'm Kai Yang. I will introduce the rest part of the presentation for you. For the parameter part, the left part shows the circuit elements calculation. The first one is the duty cycle ratio. Second one is the inductance. Third one is capacitance, and the fourth one is the resistance. We could use these formulas to calculate their values. The right part is the controller designs. Here we use the double PI controller. First, for the double PI design, we deriving the circuit formula from its characteristics for these three formulas. And then after decoupling, we eliminate the capacitance voltage. Then we will get these two formulas for P1 and P2. And then, therefore, for the inner loop, we could multiply the C1 and P1, and for the outer loop, we could multiply the C2 and P2. The result is showing this, and we will talk about their final parameters value in the later part. Based on the formulas in the last slide, we could construct these two models. The first one is the transformer isolated full bridge buck converters in simulation, and the second one is its controller modules. The third mode is the bidirectional DC converter basic model in simulation. This will be introduced in the sixth part, the result and analysis. Let's move on the technical details. This figure shows the transformer isolated and the concept diagrams. The input is DC voltage, and through the different excitation signal of these switches, the voltage is transmitted to the primary of the step-up transformer as the periodic square wave. And when the inductance of the transformer doesn't reach the saturation state, the secondary terminal will get the periodic square wave after boosting. And finally, under the action of these two diodes, the right part of this circuit is truly a buck converter. And then the DC voltage and currents are provided to the load. And this figure shows the waveform of each component in these circuits. Here, why we choose buck converter? Because the input voltage is 220 volts, the output voltage is 20 volts, and the transformer parameters N is equal to 2. So we must decrease the DC voltage to supply the source to the load. Let's start the technical details. From the formulas introduced before and plug in the known parameters, we could gain the circuit parameters here. We could find the inductance is 1.273 millihenries and the capacitance is 0.75 mFarads. However, we consider the reality and finally setting the inductance to 10 millihenries and the capacitors to 10 mFarads, which is common in reality life. And for the double PI controllers, we could also gain the parameters from the known parameters. And here, why we choose 4000 value as the numerator of the KP1? Because the 4000 is big enough, and if this value is bigger, then the output will reach the convergence faster. So here we choose the 4000. In this way, the KI1, KP1, KP2, and the KI1, KI2 could also be calculated. Then the controller will be finished. For the result and discussion part, first we analyze the transformer isolated DC converter. This is the whole system we designed. And from the oscilloscopes of its output voltage and output current, we could say the output voltage is stable in 20 volts and the output current is stable in 3 amps. And from the right two picture, this is the detailed voltage and detailed current. We could find the ripple voltage is about just 0.04 volts and the ripple current is 0.005 amps. So we could say that our designs meet the requirements at all. And for the bidirectional DC converters, this figure is its basic model and this figure is our simulation model. According to the basic model, we could find this resistor and this diode work together. Then the voltage will supplied from the left to the right, and when this resistor and this diode work together, the voltage will supplies from here to here. And from the oscilloscopes, we could find the left part is stable in 220 volts, and the right part voltage is stable in 20 volts. It shows its effect of the bidirectional DC converter. Let's move on our timeline in this project. This figure is our Gantt chart. In step 1, we find relevant information and literature and finish our proposal in this project. Step 2, we determine the method and the principle needed for the project. For the step 3, we complete the MATLAB algorithm, which is the simulation model in Simulink, and get the conclusion and analyze our waveform result. And for the step 4, we have finished the report at all. For future work, we decide to combine the transformer isolated DC converter with the bidirectional DC converter to form and design a bidirectional transformer isolated DC converter. And we have gained many knowledge in this project. We have learned the principle of transformer isolated DC converter and the bidirectional DC converter. And we have learned how to design a DC converter from the formula to calculate the inductance and capacitance. And we also master how to control the converter with the reference input signal of the resistors, and so on. And these are our conclusion in this project. And this slide shows our reference in the project. That's all. Thank you for listening.